Hello and once again welcome to our YouTube channel Engineering Shiksha. Now today we are going to learn next topic, that is the last topic in transient in RLC series circuit. So whenever we are encounter the RL circuit, our circuits or our equation could be in form of first order differential equation. Now today we are going to learn the concept of transient in RLC series circuit. So whenever you are having R, L and C combination may be possible in series or may be possible in parallel. In that case, your equation could be in the form of second order non-homogeneous equation. It means that your differential equation is having now second order equation. So in this particular lectures, we are going to discuss how to solve this type of example whenever you are encountering RLC circuit in series or it may be possible RLC circuit in parallel. So in this example, we will first of all derive the generalized solution for second order equation. After that, we will solve the numerical that is based on second order differential equation. So let us proceed. So now let us say we are having one second order differential equation that is in form of, let us say, some constant with d square I by dt square a1 di by dt plus a2 I that is equal to 0. Remember that though I have mentioned over here I, but in case of our case we can also consider this that is equal to v also. So this is a generalized variable. If suppose you have to calculate the current, then this could be a d square I by dt square, and if you want to calculate the voltage, in that case, this equation could be turned out to be d square v by dt square plus a1 dv by dt plus a2 into v that is equal to 0. So you take note of that, right? Now the second thing is that let us assume initially we are assuming that some equations or some value that will satisfy this equation. So let us say this equation is a and I am guessing some value, let us say I that is equal to e raised to st. This is some value that I am assuming that will solve this equation. So if I am assuming that I that is equal to e raised to st that will solve this equation, I can also assume that some constant k into e raised to st that will also satisfy this equation. If you remember your mathematical class, if I can say that gx is the solution, then k into gx is also solution for this second order differential equation. Now the most important thing is that why I am assuming I that is equal to k into e raised to st that is the solution. You may have some other option, right? So let us first I will explain that why I am considering this. Let us say we are having one second order differential equation. This is y double dash. It means second differentiation of y. Then let us say some value we can consider. Let us say 5y dash plus let us say 6y that is equal to 0. Let us say this is my second order differential equation and I want to satisfy this equation with any values of, let us say, y, which is actually non-zero, right? So now let us consider some, we can say that let us say some constant, let us say y is equal to 5. If you assume y is equal to 5, what is y dash? Y dash is the differentiation of phi and phi is constant, so differentiation of y dash that is 0. What about y double dash? If you take the second differentiation, that is also going to be 0. You put in this equation, you will get here 30 and 30 could never be equal to 0, right? So it means that some constant value will never satisfy this equation. Okay, now let us assume we are assuming that let us some another function. Let us say y that is equal to x square. If you assume y is equal to x square, what about y dash? Y dash is equal to twice x. And what about y double dash? Y double dash that is equal to, you will get that is equal to 2. So this is your turnouts to be a 2. This is your twice of x and this is your x square. If you put, you will not find out, or this will not satisfy your equation again. Okay, so it means that you are searching for the solution, let us say y that is equal to some constant, let us say e raised to x. Now if you take the differentiation of this equation, you will get the function itself only, right? And if you multiply with some constant factor, that constant factors come in with again multiplication factors, and you can play with your multiplication factor so that you will get plus minus sign over here, and finally your answer could be turned out to be a 0. And this is the reason we are assuming that our solution should be k into e raised to st. Is it clear to all of you? I hope you will get the idea. So now I am assuming that I that is equal to k into e raised to st, that is solution of this differential equation. So let me put it over here, a0 then d square by dt square. Instead of I, can I write down k into e raised to st? So let me write down here k into e raised to st plus a1 d by dt of, instead of this I, can I write down k into e raised to st? So let me write down k into e raised to st plus a2, and similarly here also I can write down k e raised to st, that is equal to 0. So if I will further simplify this, I will get a0. Now if I will differentiate this, k is constant. If I will differentiate e raised to st, what I will get? E raised to st, and if I will differentiate power, I will get s. Then I will take another differentiation of this. So I will get again e raised to st, and differentiation of s will become now another s, so it will become s square. Similarly, a1, k is constant. If I will differentiate this, then I will get e raised to st. This is the differentiation of e raised to st. Now differentiate this s into d, so we will get s. Then a2 into k into e raised to st, that is equal to 0. So now let me take k into e raised to st out of bracket. So k into e raised to st. So what I will get? A0 into s square plus a1 into s plus a2, that is equal to 0. Now I am having a two possibility. The possibility is that either k into e raised to st could be equal to 0, or may be possible I am having, let us say, a0 s square plus a1s plus a2, that is also equal to 0. Now two possibility could be exist, but I can say that this could not be equal to 0. The reason is that this is my solution, and for finite value of time this is never turn out to be a 0. So it means that now I am having only one possibility, is that is a0 into s square, a1 into s plus a2, that is equal to 0. So now let me finding out this root of this quadratic equation. This is my simple quadratic equation. How we can find out the root of this? So you are having two solutions, right? Let me consider, let us say, some values of s, that we are considering s1, and some values of s, let us consider s2. How to find out the solution of this equation? We know this famous expression, minus b plus or minus root delta upon twice a. So if you compare this, you will get your solution should be equal to, this is your a, right? This is your a, this is your b, and this is your c. Okay, so you can write down minus b, it means minus a1 plus or minus delta means b square. So b square means a1 square minus 4 a0 a2 divide by twice of a0. Okay, so this is my root of equation. So what I have to do, I have to first of all, whatever the quadratic equation that I can obtain from the second order differential equation, I can find out the root of this equation by utilizing this equation. So I will get this values of my root, that is minus a1 plus or minus a1 square minus 4 a0 a2, and divide by twice of a0. It means that though I am expecting only one answer, but what I will get, I am having now two solutions for this particular case. So I can say that the first solution is that, let us say, I1, that is equal to k1 into e raised to s1t, because s1 will satisfy this equation, right? And as well as I2, that is equal to K2 into e raised to S2t. This is my another solution, and this equation is also satisfied this equation, right? So it means that I1 is the solution for this particular differential equation. I2 is also the solution of this particular differential equation. We also learn in our mathematics class, if GS is the solution, if Hx is the solution, then Gx plus Hx is also the solution. So it means that I can say that I1 and I2, that is the addition of I1 plus I2, I will consider another variable, let us say I. So I can say that I, that is nothing but equal to I1 plus I2, that is also solution. So I can say that K1 e raised to S1t plus K2 into e raised to S2t, this is also my solution. So remember, this is your generalized expression for second order differential equation. So if you are having a second order differential equation that is in this form, then your solution or generalized solution could be in this particular form, where I, that is the k1 e raised to s1t plus k2 e raised to s2t. Where to find out s1 and s2? How you can find out? You are having a quadratic equation, you solve the quadratic equation and find out the root of your characteristic equation, then you can get the value of s1 and s2, and this is your current value, right? How to, or remember, this is just I am considering current also, but you can expect current and as well as voltage also. Okay, so in this case, how to calculate the values of K1 and K2? You have to solve this equation. Okay, and you have to consider your initial condition. In case of initial condition, you will get the values. But here the one problem is that you are having actually two unknown. Okay, so here you have to solve two initial condition. How to solve that we will discuss slightly later on. So this is the possibilities that exist for second order non-homogeneous equation. So we are finding out the root S1 S2, that is equal to minus a1 plus or minus under root of a1 square minus 4a0 into divided by twice of a0. Here there will be the characteristic of root is actually having a four possibility. The first possibility is that your a1 square value is greater than 4a0 a2. It means that this quantity is higher than this quantity. If you subtract this, you will get a positive number, right? So it means that this will ultimately turn out to be a real number. And because of this negative sign, you will get your root, that is your negative, real, and as well as unequal root, because this is or because of this plus or minus sign, right? So your generalized solution that we already discussed right now, that is k1 e raised to s1t plus k2 e raised to s2t. Now there will be a second possibilities also exist, and the possibility is that your a1 square, that is equal to 4a0 a2. It means that these two quantities are same. If these two quantities are same, this is going to be 0. It means that your both the roots, okay, this is not plus or minus sign now. It means that both the roots are now equal, and this is a negative, real, and equal root. So in case of second order differential equation, if you are having negative, real, and equal root, how you can solve? This is your expression, that k1 plus k2t e raised to s2t. If you are not aware with this thing, you have to refer your mathematical books. Now the third possibility is that your a1 square is less than 4a0 a2. So in this particular case, if I am saying that a1 square is less than 4a0 a2, this quantity turn out to be a negative. Agree with me? And if you take the root of this negative number, ultimately it is going to be a imaginary number, right? So it means that this is your real and this is your imaginary part. Okay, real and plus or minus imaginary. So you can say that ultimately this is sigma plus or minus j omega form. Okay, so if you put the values of sigma plus or minus j omega in this particular equation, so you will get sigma constant, okay, and e raised to j omega. If you expand your exponential function, that is cos omega t plus j sin omega t, your finally your answer could be turn out to be in this particular form. So this is the third possibilities that is also exist. Okay, then there will be another possibility. The fourth possibility is that your a1, that is equal to 0, but a2 is not equal to 0. a1 is equal to 0, it means what? Your real part of this root is going to be a 0. There will be only imaginary part is exist. So you can say that you are having a conjugate imaginary number. So your sigma is going to be 0. So if you put sigma equal to 0 in this equation, finally you will get this expression, right? So remember, these are the total four cases that you must have to be remember in case of second order differential equation. So whenever you are having second order differential equation, out of these four possibilities, any one possibility could be exist. If you remember your control class, in control class we have discussed this thing. Okay, this is your second order differential equation, that is s square plus 2 zeta omega ns plus omega n square. And whenever you are having a second order this kind of equation, your natural oscillation omega n, that will depends on 1 upon under root of LC. So the thing is that your zeta will decide what kind of response that you can obtain from second order differential equation, whether it is undamped system, whether it is critically damped system, whether it is overdamped system. So everything come under the values of zeta, and this is the possibilities, and out of these four possibilities, that any one possibilities, whether critically damped, undamped, overdamped, so that possibility could be exist, and that we will discuss in our control class in a detailed manner. Okay, but in network class I have skipped this part right now. So now let us discuss about the steps that we are going to follow for our second order differential equation. So first step, so we will first of all draw our equivalent circuit for t greater than 0. So just like in our case, let us say I am doing my switching at, let us say, instant t equal to 0. So what I have to do after that, I will apply a KVL, or I will apply the KCL, or maybe node voltage analysis, depending on which parameter I have to calculate. Just like in our previous case, let us say we want to calculate current, we will apply KVL. Then we will calculate the root of second order differential equation. As we are having a second order, or we can say that RLC combination in this particular case, so we are having a second order differential equation. So we will calculate the root of that second order differential equation. How we can calculate the root? Just like just we have explained in our generalized case, minus b plus or minus root delta upon twice a. So by utilizing that equation, we can calculate the root of our second order equation. Then in next case, we have to find out the particular solution. So particular solution means you want to calculate K1 and K2, okay, to calculate your final or particular solution. Now here one thing you must have to remember, that in second order equation you are having two unknown. So definitely you require two initial condition, or you can say that two equation that will satisfy. Then and then only you can able to calculate two unknown, that is K1 and K2. So what we are doing, let us say whatever we are having a variable. In previous case, what we are doing, how to calculate the particular solution, we will consider, let us say t equal to 0. We will consider initial condition, and in our general solution, we will put the value of t equal to 0 in our general equation, generalized form, right? That what we did in our first order differential equation. Here also we will do the same thing, but now we are obtaining only one equation, okay, and one unknown. How to calculate the second unknown? We will differentiate our generalized solution, and we can obtain our second constant k by using again initial condition. So it means that, let us say we are having one expression, let us say in terms of I, that is equal to something, right? So now we are differentiate this equation, that is di by dt. So it means that not only we are focusing to calculate at t equal to 0 only current, we can also calculate the rate of change of current. Or same way, we are not only focused on voltage, we will also focus on dv by dt. And if we are having these two parameter at initial condition, we are having a generalized solution, okay, normal form and as well as differentiation form. We will put the value of t equal to 0, okay, and we will calculate this two variable. So now this is the steps that you have to follow to solve our second order differential equation. So now let us proceed with our first example, and you will get good idea that how to solve second order differential equation. Okay, so now let us discuss our today's first example. So in a series RLC network of figure, the switch K is closed at time t equal to 0. It means that this switch is closed at some time, let us say a 9 a.m. This switch is going to be a close, right? We have to calculate the particular solution for the current which is flowing in this particular circuit. It is given that the applied voltage V, that is equal to 20 volt, R resistance value, that is equal to 9 ohm, L inductance value, that is 1 Henry, and capacitance value, that is 0.05 farad is given. Okay, so let us start our example. Okay, first of all, we have to consider what exactly the situation after t equal to 0. So let me draw the circuit for exactly after a time t equal to 0. And what we are doing, we will follow our steps. First of all, we will apply the KVL. Okay, we will try to find out the characteristic equation. We will calculate the root, and after that, we are trying to solve our particular solution. So let us say this is the current that is flowing in this particular circuit, okay, and we are going to apply a KVL. So if we are going to apply a KVL for this particular loop, what we can obtain, let us say some resistance value, that is R into I. This is my voltage drop across my resistive element, plus inductive drop, that is L di by dt, plus voltage drop across this capacitor, that is 1 by C integration I dt, that is minus V. If you take it on the right hand side, you will get that is equal to my supply voltage V. Now let me put this value, numerical value. So resistance value, that is 9. Okay, so that is 9 into I plus L is given, that is 1 Henry. So this is di by dt only. Then 1 by C, that is 1 divided by 0.05. So that is nothing but 1 divided by 0.05, that is equal to 20 integration I dt, that is equal to 20 watt. Is this point is clear? Okay, we require our equation that could be in the form of d square I by dt square di by dt. So to get that form, let us differentiate this equation. So what I will get, let me start with this point. I will get, if I will differentiate this, I will get d square I by dt square plus If I will differentiate this, I will get 9 di by dt, right? Plus 20. If I will differentiate, this integration term will get cancelled, so I will get 20i, that is equal to. Now 20 is constant, so if you differentiate, you will get 0. So remember this equation. This is your second order differential equation. So let me convert it our standard form. So you can take it, let us say d square by dt square. Instead of d square by dt square, you can write down directly, that is s square. And instead of d by dt, you can write down that is equal to s. So I will get my final expression, that is s square, right, into I plus 9 into s into I plus 20 into I, that is equal to 0. So I could not be equal to 0. So it means that my solution should be s square plus 9s plus 20, that should be equal to 0. So let me write down my expression once again here. I will get s square plus 9s plus 20, that is equal to 0. Now remember, this is my characteristic equation and I will find out the root from this characteristic equation. So how you can calculate the root? That is very simple. You are having, let us say, s1 and s2, that is your two root. So you can use this expression minus b plus or minus root delta, where delta is nothing but b square minus 4ac divided by twice of a. What is the value of a? If you compare this equation, your a, that is equal to 1. What is the value of b? B is 9. And what is the value of c? C, that is equal to 20. So you put this equation, you will get minus 9 plus or minus 9 nines are 81. So I will get minus 81. 4 into a, that is 1, and c, that is 20, divide by 2 into 1. So if I will further simplify this, I will get my value of characteristic equation, that is minus 4 and minus 5. So it means that my S1 and S2 value, that is equal to minus 4 and minus 5. So here I will get two root, that is minus 4 and as well as minus 5. So it means that my generalized solution, okay, we have already discussed my generalized solution, let us say I of t, that is equal to k1. So let me write down k1 e raised to minus s1t. So value of, let us consider this is your s1 and this is your s2. So I will get e raised to minus 4t plus k2 into e raised to minus 5t. This is my generalized solution. Let us mark it as equation number 1. Now in this particular case, now we are shifting from our initial condition. Why we are required to calculate our initial condition? Because we want to calculate the value of these two constant k1 and k2. In our first order differential equation, we have to always deal with only one variable, or you can say that one constant k, right? So we are considering one initial condition only. But right now, what is the situation? The situation is that you have to deal with, or you have to calculate two variables, that is k1 and k2. So we already, I have discussed in my previous slide that what we are considering, let us say if I is my variable, we are calculating I initial condition also, and we are calculating di by dt for initial condition also. Remember that we have directly shift from our t greater than 0. But most of the time in our previous step or in our previous lecture, what we are doing, we are starting with t less than 0 minus, t 0 plus, and t greater than 0. So now let us consider our situation, that what is the situation at t equal to 0 plus, that is just after the switching. So this is my situation, that is exactly just after the switching. This is my condition. Okay, so at this condition, just after the switching, my inductor will behave as a open circuit. Why it is so? Because inductor will come in influence or contact with this energy first time. So whenever inductor will come in contact with the energy first time, it will behave as a open circuit, right? Whenever inductor will start charging, it will behave as a open circuit. So you can say that this is t equal to 0 condition for inductor, and inductor will behave as a open circuit. So in this particular case, if I am seeing that what is the value of current I that is flowing in this circuit, as this is the open circuit, you can directly say that's a 0 ampere, right? So current flowing through this circuit, that is equal to 0 ampere. What about the capacitor voltage VC? If I will put the multimeter, capacitor voltage VC is also turn out to be 0. Why it is so? Because capacitor will behave as a short circuit. Remember, whenever capacitor will come in contact with the energy first time, it means that at time t equal to 0, capacitor is also behave as a short circuit, okay, because capacitor start charging, and during the starting of the charging, capacitor will behave as a short circuit. So it means that I can say that voltage across capacitor is 0 and current that is flowing through inductor is also 0. So it means that if I will discuss, or if I will focus on this equation, okay, if I will focus on this equation, let me write down what is the situation right now. The situation is that I is equal to 0, right? So it means that, let me change the color. So it means that when current is 0, it means that you can say that this quantity 9 into I is going to be 0, right? What about this 20 into integration I dt? This term represent your capacitor voltage Vc, right? This term represent your capacitor voltage Vc, and that is also turn out to be a 0, because at initial condition capacitor will behave as a short circuit. So this will behave as a short circuit. So it means that this term 20 into integration I dt, that is also equal to 0. Remember, at time t equal to 0 plus only, okay. So it means that my di by dt that is equal to di by dt that is equal to 20, right? So di by dt that is equal to 20, but exactly at t equal to 0 plus time only, okay. So at time t equal to 0 plus, the rate of change of current that is also equal to 20 ampere per second. So it means that now I'm having a two variable at time t equal to 0. So at time t equal to 0, my current I that is also equal to 0, and as well as if I'm going to calculate the di by dt, that is equal to 20 ampere per second. So now let us consider our, or try to calculate our variable. So let me first put the value of t equal to 0 in this equation, equation number 1. So what I will get? I of 0. So I of 0 at initial condition we already calculate, that is equal to 0. So it means that 0 is equal to k1 e raised to 0, right? Plus k2 into e raised to 0. So it means that I can say that my one equation, let me write down here, I will get that is equal to k1 plus k2 that is equal to 0. Now I am having another variable to calculate the second constant. Remember, you are having two variables k1 and k2. So by using only single equation, you cannot solve it. So let us consider our second part. So let me first differentiate this equation, because we are having value at time t equal to 0. What could be the rate of change of current? So let me differentiate this equation. So I will get di by dt that is equal to k1 e raised to minus 40, right? If you differentiate e raised to minus 40, what you will get? E raised to minus 40, and then you differentiate minus 40, then you will get minus 4. Then again you are having another variable, that is k2 and e raised to minus 5t. When you differentiate e raised to minus 5t, what you will get? E raised to minus 5t, and then you differentiate minus 5t again, you will get minus 5. So let me put it over here, minus 5. Now let me put the value. So we know that di by dt exactly just after the switching, that is equal to 20. So let me write down here 20, that is equal to minus 4 k1. Okay, right now we are at the stage of t equal to 0. Okay, just after the switching. So you can put it over the value of e raised to 0. So this is e raised to 0 is 1. So minus 4 k1 minus 5 k2 that is equal to 20. So it means that now I'm having a two equation. Okay, this is my first equation and this is my second equation. So if you solve this, you will get your two unknown. First let us multiply 4 to this equation. So what you will get? 4k1 plus 4k2 that is equal to 0. So now if you add these two quantity, k1 get cancelled, you will get k2 value that is equal to 5k2 that is equal to, okay, so k2 that is equal to minus 20, right? You have to just subtract, or you have to, let us say, you have to just add these two quantities. So 4k1 and minus 4k1 get cancelled, minus 5k2 and plus 4k2. So this is minus k2 that is equal to 20. So you can say that k2 that is equal to minus 20. You put this value in this equation, so you will get k1 that is equal to plus 20. Okay, so now you are having two variables or two initial condition, and you can get the two constant. So k1 value, that is 20, k2 value, that is also equal to minus 20. You put in this equation, so your final particular solution, that is I of t, that is equal to value of k1 is 20, so put it over here, 20 e raised to minus 40 plus, I'm sorry, this is minus. So I of t, that is equal to 20 e raised to minus 40 minus 20 into e raised to minus 5t. So this is your final expression. So this is all about our method, that how you are going to solve second order differential equation. So in the next lecture we will discuss some more example, and I hope you will enjoy this lecture series. Thank you.